Yes. I will start possibly the migration of the text into specific data facility. So my presentation will be divided into 5 parts. One depends on data stories are very complete theories and the data variability due to complex cognitive and the cognitive environment. In addition, only limited data are known due to limited type and time. This fact makes it difficult to give reasonable safety assessment to the continuous system. Therefore, it is important to optimize the study investigation software to obtain as much valuable information. In this study, we propose a method to solve the issue. The spatial variability can be characterized by the benefit theory. This benefit theory, the spatial variability can be related by the unconditional random phase simulation. As we can see in the figure 1, this figure shows the distribution of the soil properties. And the safety data, the impact of the safety data can be related by the conditional random phase simulation. As we can see in the figure 2, the mean and the variation of the soil properties is constrained by the conditional random phase. And the figure on the right shows the flow procedures of the proposed method. First one, we perform 1,000 simulations. And then we can get 1,000 samples and 1,000 factor of safety. Then we calculate the DMN rank coefficient between each element and the factor of safety. And then we calculate the DMN rank coefficient at all the available possible locations and choose the maximum value at the next possible location. Finally, here the target number of possible locations is reached. Okay. The figure 3 gives the reason why we perform 1,000 simulations. As we can see, within 1,000 simulations, the factor of safety and the DMN coefficient are converged. This figure shows the specific procedures. As we can see, after 1,000 simulations are performed, we can obtain 1,000 samples of soil properties and 1,000 factor safeties. And we can calculate the DMN coefficient at each available possible location. This study, we can see there might be not a possible location. After that, we finally reach the target number of possible. Here, without work of generosity, we choose an ungraded slope as an analyze example. Table 1 shows the soil properties, and one of the unconditional simulation sample is detected as a real and a true slope. This method is validated by a comparison study between the proposed method and the traditional method. In the traditional method, the borehole location has equal distance. So the engineers might need to judge the potential study area based on their own experience. Therefore, there might be three levels of the judgment: good judgment, moderate judgment, and poor judgment. In good judgment, the study area is considered to be perfectly estimated. So all the boreholes are located in the study area. In the moderate judgment, all the boreholes are located at the slope domain, because the slope domain is the most dangerous area in the slope model. In the poor judgment, the study area might be overestimated. These figures show the corresponding borehole patterns: good judgment, moderate judgment, and the poor judgment of the proposed method. We choose three indexes to estimate the effect of the proposed method. First index is factor of safety. The second one is the location of slip surface. The third one is lighting volume. The location of the slip surface might be determined by the nodal displacement method and the max shear strength increment method. As we can see in the figure 5, when the 35% of maximum node displacement is chosen, these methods can have a good agreement. In this study, the nodal displacement method is chosen, and for the uncertainty of the location of slip surface, this uncertainty might be characterized by the typical point at the location at the slip surface. The point A and B are in the study area, and the point C is related to the planar mechanism. For the result of factor of safety, you can see for all the methods, the mean of the true factor of safety can be calculated by a range of plus or minus a time of sigma. It means the mean of the factor of safety can be well estimated by all the methods, but the field with of factor of safety can be reached most for the good judgment proposed method. And for the location of the slip surface, as we can see, good judgment can give the most accurate estimate of the location of slip surface with the least number of boreholes. And the moderate and good judgment cannot give estimate of location of slip surface, even much investigation effort made. The proposed method might need more effort to give an accurate estimate of the location of slip surface. The study for the without finding volume, similar conclusions can be obtained. Sometimes we concern the features of the slope itself, but we might pay much more attention to the meaning behind the indexing. So the robust analysis and the risk assessment are performed in this study. The figure 10 shows the concept of the robustness. As we can see, the figure on left, when the variation of the input parameters results a large variation of the system response. So we can see the right side gives more robust. The figure on the right gives the So there might be another index to characterize the robustness, which is the signal to noise ratio. The results showed that the most robust estimate of the slope system is given by the proposed method, followed by the good judgment. We also might calculate the risk assessment by the total loss. Here we can see the proposed method gives the last expected total cost and at least 90% loss is avoided. The first slide summarizes all conclusions in this study. As you can see, the proposed method can optimize the location and the number of hosts at the same time. And it gives the most robust estimate and minimum loss of the slope system. In addition, the proposed method provides reference to the design of uneven distance bottom patterns. In this study, only one homogeneous slope is considered. So the finding of the proposed method can need further study. Thanks for your attention. Anyone can
Okay. Are there any questions online?
May I ask a question?
Yeah, go ahead.
Yeah, thank you, Dr. Nietzsche. It's a great presentation. Just in general, what's this type of borehole used for? For drainage?
So you mean the how we use the fall patterns?
Yeah, yeah. It's nice. I say a lot of calculation there. Just what's this type of application you can use in the like what you mentioned the background slide. What's a kind of a direct application you can use this the kind of method you propose? I'm curious.
Okay. In this study, only the on-grade scenarios are considered. So maybe if you want to use this method in a more complex scenario, you might be go further study testing the effectiveness of this method.
Okay. Okay. Yeah. Thank you.
Thank you very much. Well, while we're waiting, one more question. I think you said there was something about 1,000 different realizations of a simulation.
Yes.
So what do the realizations do? What's the purpose of all these many simulations?
Oh, because there are some uncertainties in the input parameters. So the variation of the parameters will result in the variation of the system response. So we need to perform 1,000 simulations to give the whole variation of the system response.
Okay. So it's because of the uncertainty in the parameters.
Yes.
And then when you make certain conclusions, are they based on like the worst case scenario that it could be? What I mean is that it seems like you have many realizations, right?
Yes, then I understand.
But ultimately, a sample of soil is, I mean, it is what it is. In real life, there is one realization, right?
Yes, because we don't have sufficient data. So we only know the data we have. We don't know the data at the location we don't have.
Okay, understood. Thank you. Now, oh, okay. Put this thing on for one moment. The next talk. Actually, while we're waiting, just to make sure Is Dorian Davis here? Okay, we understood. Is Justin Ann present? Justin Ann? Oh, yeah, okay, that's it. Okay, sorry, never mind. Yeah. Okay, so I think we're running a little behind schedule, but if we're missing on presentation, it'll probably get us close to back to schedule. So we're waiting to upload the next presentation onto the thumb drive. It'll be just a minute.